Hello, seventh graders. This is Mrs. Abbott from CMS, and I'm here to teach you about science. And though I respect Mr. Gaylor and Mrs. Wagner a lot, I'm not going to waste your time talking about mascots. This is all about science. Maybe one thing I'd like to clear up for you. At CMS, we like to be referred to as the Mustangs, not the Colts. If you could just keep up, Mrs. Wagner and Mr. Gaylor, we'd really appreciate it. Okay, on to science. Now, 2 weeks ago, you learned about physical and chemical changes. If you can see my board here. Okay. And you learned that a physical change does not create a new substance, but a chemical change does create a new substance and it has new properties. That's going to be important. Once a substance has been chemically changed, it cannot be changed back into its original form. Now, the way that a chemical change takes place is through something called a chemical reaction. And that's what we're going to be learning about this week is chemical reactions. Now, I want to do a chemical reaction for you. Let me just move you back a little bit here. See if we can get this lined up. Here we go. Okay. I have a candle here. You also learned last week that a chemical change happens more quickly if you add some heat to it, because that gets those atoms and molecules moving faster, so they rearrange quicker, and that makes the chemical reaction happen faster. So I'm going to add some heat to this sugar. This is just regular old sugar, like you'd use to make cookies or something like that. And I am going to start to warm it up on top of this flame. We're going to try to get a chemical reaction to start happening. Now, maybe can you see the smoke being made there? Yep, can definitely see the smoke and see the bubbling happening there. And also, what used to be white sugar is now turning dark brown. And can you hear it? I don't know if you can hear the bubbling happening there. I'm going to go back to my flame. Now, also, you learned the signs that different chemical reactions are taking place. So, what are some of the signs you're seeing here? What types of things are the hint that we've got a chemical reaction happening? Okay, so there's a color change. What used to be white crystals are now turning more and more black as we go. We've got bubbles forming, so that means there must be a gas being produced. There is smoke, so that's another clue that there's a gas being produced. And if you were here in my kitchen with me, you would definitely be smelling something. It's kind of a sweet smell. Smells a little bit like if you left those cookies in the oven for too long and they started to burn a little bit. That would be the kind of smell you're getting here. Now, let's give you a close up. This is what my sugar has now become after the chemical reaction. Okay? All right, so this sugar has become something else. I cannot turn it back into the white crystals anymore. Those are totally gone. So we know it's got to be a chemical change. Okay, now scientists use something called chemical formulas and chemical equations to figure out what happens during a chemical reaction. And that's what we're going to be learning about this week is those formulas and equations. Now, if you heard the word formulas and equations and you're thinking, this sounds like math. Well, it kind of is. It is a little bit about like math, except that instead of using numbers, we're going to be using atoms and molecules. Okay, so let's go back to my board here. Blow out my candle. Let's see if you can see my board. Okay, so I'm going to move this. So what did we just witness? All right. So we had some sugar and we added some heat and it became a black solid and it made some kind of a gas. All right. So what we have left here is that black solid. And we saw the smoke coming off of it. So we know some kind of a gas was formed. So this is the beginning of our chemical equation. Now, let's add to it here. All right. You learned in facts class probably that sugar was a kind of carbohydrate. Carbohydrate. Okay, so that means that our black solid that was created was actually carbon. And the word hydrate, water. So we know that this is actually carbon and water. So that gas that you saw coming up there was actually water vapor coming up. Now, we can also use the fancier version, the chemical version of sugar here, which is C6H12O6. Feeling like some science now, aren't you? Okay, so carbon, hydrogen, and oxygen. This is just sugar. And it's going to make some carbon and some water. Now, H2O is probably one of those chemical formulas that you've seen before. These are called formulas. It's the way we represent things in chemistry, the atoms, how they're combined with in different ways. Okay, so notice I have carbon on this side. I've got carbon on this side. I've got hydrogen on this side. I have hydrogen on this side. Oxygen on this side and oxygen on this side. Okay, so law of conservation of mass, which is something you've already learned about, says that matter cannot be created or destroyed. So if I've got carbon here, I have to have carbon after the reaction. If I've got hydrogen and oxygen before the reaction, I have to have them after the reaction. This is law of conservation of mass. Now, thing is, if matter cannot be created or destroyed, I have to have the same amount of carbon before the reaction as after the reaction. That's what we call balancing equations. Okay. I'm going to balance this equation, and this one is probably going to be quite confusing at first, and that's okay. We're going to do simpler ones together in a little bit, but let me just show you what it would be for the reaction I did. First, we got to count, see how many we've got here. All right, so here's step one. I got to count my carbons, my hydrogens, and my oxygens on this side. Okay, I've got 6 carbons, C6. I've got 12 hydrogens, H12. And I've got 6 oxygen here. Okay. That's how many I have on this side of the equation. Let's go to the other side of the equation. I have carbon, hydrogen, and oxygen. All right. I just have 1 carbon here. 1. H2, so I've got 2 hydrogen, and I have 1 oxygen. This breaks the law of conservation of matter because I've got different amounts of atoms on either side of this equation. So I have to do what's called balancing. Okay, so let's take a look at these carbons. 6 on this side, 1 on this side. You might be tempted to put a 6 here. Doesn't work that way. You are only allowed to put numbers in front. Now, the fancy sciencey word for this is called coefficients. And I don't know, I'm wondering if that orange is showing up there. I don't think it is. Let's try green. Hopefully that's better. Okay, so if I put a 6 in front of this carbon, I have now created 6 carbons. Ooh, balances. Now, I've got 12 hydrogens here. I have 2 hydrogens here. I need more hydrogens. but I can only put numbers in front here. So if this is H2, if I put a 6 right here, I'll have 6 H2s, which will make this 12. And that now balances with the 12. But I made 6 H2Os. I also made 6 O's. So this became a 6. And now we are balanced. Again, if this one didn't make sense to you, that is totally okay, because we're going to be doing some simpler ones, and you are not going to be doing anything this complicated when you're doing your homework. So let's do some much simpler ones. I've got to switch to my other, I guess I can use this board. Just erase it. You have to have 2 skills to be able to balance equations. And one of those skills is counting how many atoms you have on each side. So first we're going to practice the counting. Get my cheat sheet here so that I have, wrong paper. All right, this is just like school. When your teacher loses the paper they're looking for, I'm going to pause you a minute and find that paper. Okay, I'm back. I found my paper and it slipped underneath my boards. Okay, so I decided as long as I was taking a break, I might as well pre-write my stuff here. We're going to practice counting atoms. Now these are chemical formulas. You don't have to know what all these chemical symbols stand for, but just know that every time you have a capital letter, it means there's another atom there. So this is actually the chemical formula for salt, sodium chloride. Plain old salts that you sprinkle on your food. It's the same stuff you got in your house. Okay, it's made out of Na, which is sodium, and chlorine, which is Cl. Now, if I was going to count these, that's what we're practicing, is counting these atoms. I just have one of these Nas, and I have one of these Cls. Easy as that. Let's go to our next one here, CaCl2. This is calcium chloride. It's made out of calcium and again, chlorine, just like our salt here. Okay, I have one of these Cas, and because of this 2 right here underneath, I have 2 chlorines. This is what's known as a subscript, and it says how many of what it's right behind. All right, moving down here, this is a little carbon dioxide. You've heard about that one, CO2. Ooh, here's something new here. Here's one of those coefficients in front that we use to balance equations. This means I have 3 of these CO2s. So one of them, and I have another one. I'll put one up here, and I have another one. Okay, I have 3 CO2s. So how many carbons do I have? 1, 2, I've got 3 of them. How many O's do I have? How many oxygens do I have? Well, I've got 2 here. I've got another 2 here, that's 4. And I've got another 2 here, that's 6. So that's how I would count 3 CO2s. Now my last one here gets the most complicated of all. It says I have 2 CaSO4s, 2 calcium sulfates is what that chemical formula is. Okay, so not only do I have one of these, I've got another one. So if I put another one right here, ooh, that's some bad writing. 2 CaSO4s. Okay, 1, 2 Cas. Yep. 1, 2 S's. And I've got 4 O's here and 4 O's here, so that makes a total of 8 O's. Now, you should play this video again if you're not understanding this part. Also, I'll have a script of exactly what these examples are, so you can go back to them and look at how they work. Okay, so that is counting atoms. You will be doing that as part of your assignment this week. All right, move this board. You are also going to be balancing equations this week. Really sciencey stuff. Okay, Here is a chemical equation for making water. Recognize that one? H2O. Okay. So maybe I can move you a little closer here. All right. So in order to make water, we have to take hydrogen and we add to it oxygen and we make water. Okay, balancing equations, 2 steps. First, you've got to count your atoms, which is exactly what we just did on this board, right? Counting our atoms. Okay. On this side of the equation, I've got hydrogens and oxygens. How many do I have? Okay, I've got H2, 2 hydrogens, O2, 2 oxygens. That's for this side. Now we need to look at the other side because law of conservation of mass or law of conservation of matter, they interchangeable, says whatever I have before the reaction, I have to have after the reaction. Matter cannot be created or destroyed. All right, what do I have over here? H2, okay, 2 hydrogens, O, 1. All right, hydrogens are balanced. That's looking pretty good. I got a problem here. I've got 2 oxygens over here, only 1 oxygen over here. The only place I'm allowed to put anything is right in front. I'm only allowed to do a coefficient. So I need 2 O's. So I got to put a 2 here to make those 2 O's. But I didn't just change the O's. I also changed the H's. Now I have 2 H2s. Get my other color here. I used to have 2 O's, but now I have, here, H's. I used to have 2 H's, but now I have 4 H's because I put that number in front. So, okay, we got it. But I did make my 2 O's. All right. O's are happy, nice and balanced. We got a problem with our H's. We've got to go back to this side again. When you're balancing, sometimes you're going back and forth. All right, 2 H's, but I need 4 H's. So I need to go over here and put a 2, because then I'll have 2 H2s, which makes it 4. Now everything is balanced and we are following the laws of conservation of matter. Again, go back over this video again, go back over my notes so that you can see how this is done. Let me give you a little close-up here of exactly how this equation balanced. We're going to do one more together, and then there'll also be a practice one that I take you through on your homework. So let's get rid of this one and put up a new equation. Okay, we just made some water. Let's see, what's our next one going to be? Okay, I am going to take some magnesium, Mg. That is the, and we're going to add this little, it's a metal, and I'm going to take this metal, this magnesium, and I'm going to drop it into some hydrochloric acid, HCl. And it is going to make, I'm going to run out of room here. I'm going to write this smaller and then I'll be right back. Okay, and we are back and took advantage and just wrote out the whole thing while I had paused you. Okay, so this is another chemical equation. This is a magnesium metal and I'm adding it to some hydrochloric acid. And what it's going to create is some magnesium chloride, and it's actually going to bubble up and give off some hydrogen gas. Again, you don't have to understand the chemical reaction happening here. You just have to look at balancing this to follow the law of conservation of matter that says that matter cannot be created or destroyed. Elements, atoms that are here before the reaction have to be the same amount after the reaction. So step 1, count your atoms. Here we go. Okay, Mg, there's no little subscript after it. There's just one of those. Got 1 Mg, here, which is magnesium. My hydrogen here, my H, again, there's just one of those. And my last one, my Cl, my chlorine, again, there's just one atom of that. So one of each of these atoms. Now I've got to go after the reaction. What do I see over here? Okay, 1 Mg, there's no little number after that. This 2 only goes with the Cl. So I've got 1 Mg. H's. If I go over to my H, there are 2 H's here. Notice how the atoms got rearranged a little bit. Cl, I've got a 2 after it, so I have 2 Cl's. Now you check. Is my equation balanced? Sometimes it is. This case it is not. Magnesiums, they match. Good. Hydrogens. Ooh, I've got 2 hydrogens here and 1 over here. Chlorines, I've got 2 chlorines here and only 1 over here. Okay, let's think about our hydrogens first. I need to make 2 hydrogens on this side. I find my hydrogen in my chemical formula. I can only put a number in front. How many do I need? 2. So I put a 2 right there. Okay. So I just created 2 hydrogens. Not 1. Now I have 2. But look, that chlorine is there as well, and it now has a 2 in front of it as well. So I've also just created 2 chlorines. That's a good thing because that's what I needed over here. All I needed to do in this particular chemical equation is put 1, 2. Again, this is called a coefficient right here in front of this chemical formula for hydrochloric acid. And I'm all done. See all these other blanks? It's okay to leave those blank. You only put in the amount of numbers you need to balance the equation, to make it follow the law of conservation of matter. Again, go back through this video, watch to see how this is done. I will also have a script from this where you can see all these examples, and you'll have examples in your homework. Okay, speaking of homework, what are you going to be doing this week? All right. So let me get you a light. Okay, you're going to be doing 2 pages from your workbook again. And in that, it is a review of the signs of a chemical reaction taking place. And it also has some vocabulary. You'll see some of the vocabulary that I've been using today, like coefficients and subscripts. You'll also be adding vocabulary for what the pieces and parts of a chemical formula are, and chemical equations and chemical reactions. So all that different vocabulary is coming. So when you do your homework, you are going to have a vocabulary fill in the blank is going to be the first part of it. And then the second part is going to be practice counting atoms, and then you're going to have practice balancing equations. There are examples in the homework. Go back to this video, check the examples here. Okay, and as always, go to your teacher's office hours if you have any questions. And I hope you have fun doing some real chemistry this week. I hope you enjoy getting into the science, because science is real. It's real fun. That's what it is. All right, have a good week, 7th graders.